numerical equivalents of the letters. 5 capital and small Greek letters. 6. The letters marked with asterisks are those brought to Greece from Phoenicia by Cadmus. 7. Name of the Greek letters. 8. Nearest English equivalents to the Hebrew, Greek, and Samaritan letters. Note: when used at the end of a word, the Hebrew tau has the numerical value 440, kaf 500, mem 600, nun 700, pe 800, zadi 900. A dotted alpha and a dashed aleph have the value of 1000. Continued. An introduction to the Pythagorean theory of numbers. The following outline of Pythagorean mathematics is a paraphrase of the opening chapters of Thomas Taylor's Theoretic Arithmetic, the rarest and most important compilation of Pythagorean mathematical fragments extant. The Pythagoreans declared arithmetic to be the mother of the mathematical sciences. This is proved by the fact that geometry, music, and astronomy are dependent upon it, but it is not dependent upon them. Thus, geometry may be removed but arithmetic will remain. But if arithmetic be removed, geometry is eliminated. In the same manner music depends upon arithmetic, but the elimination of music affects arithmetic only by limiting one of its 1 2 3 4 5 6 7 8 9 a b c d e f g h i j k l m n o p q r s t u v w x y z expressions. The Pythagoreans also demonstrated arithmetic to be prior to astronomy, for the latter is dependent upon both geometry and music. The size, form, and motion of the celestial bodies is determined by the use of geometry. Their harmony and rhythm by the use of music. If astronomy be removed, neither geometry nor music is injured. But if geometry and music be eliminated, astronomy is destroyed. The priority of both geometry and music to astronomy is therefore established. Arithmetic, however, is prior to all. It is primary and fundamental. Pythagoras instructed his disciples that the science of mathematics is divided into two major parts. The first is concerned with the multitude, or the constituent parts of a thing, and the second with the magnitude, or the relative size or density of a thing. Magnitude is divided into two parts, magnitude which is stationary and magnitude which is movable, the stationary pair having priority. Multitude is also divided into two parts, for it is related both to itself and to other things, the first relationship having priority. Pythagoras assigned the science of arithmetic to multitude related to itself, and the art of music to multitude related to other things. Geometry likewise was assigned to stationary magnitude, and spherics used partly in the sense of astronomy to movable magnitude. Both multitude and magnitude were circumscribed by the circumference of mind. The atomic theory has proved size to be the result of number, for a mass is made up of minute units though mistaken by the uninformed for a single simple substance. Owing to the fragmentary condition of existing Pythagorean records, it is difficult to arrive at exact definitions of terms. Before it is possible, however, to unfold the subject further, some light must be cast upon the meanings of the words number, monad, and one. The monad signifies the all-including one. The Pythagoreans called the monad the noble number, sire of gods and men. The monad also signifies the sum of any combination of numbers considered as a whole. Thus, the universe is considered as a monad, but the individual parts of the universe such as the planets and elements are monads in relation to the parts of which they themselves are composed, though they, in turn, are parts of the greater monad form of their sum. The monad may also be likened to the seed of a tree which, when it has grown, has many branches, the numbers. In other words, the numbers are to the monad what the branches of the tree are to the seed of the tree. From the study of the mysterious Pythagorean monad, Leibniz evolved his magnificent theory of the world atoms, a theory in perfect accord with the ancient teachings of the mysteries, for Leibniz himself was an initiate of a secret school. By some Pythagoreans the monad is also considered synonymous with the one. Number is the term applied to all numerals and their combinations. A strict interpretation of the term number by certain of the Pythagoreans excludes 1 and 2. Pythagoras defines number to be the extension and energy of the spermatic reasons contained in the monad. The followers of Hippasus declared number to be the first pattern used by the demiurgus in the formation of the universe. the one was defined by the Platonists as the summit of the many. The one differs from the monad in that the term monad is used to designate the sum of the parts considered as a unit, whereas the one is the term applied to each of its integral parts. There are two orders of number, odd and even. Because unity, or one, always remains indivisible, the odd number cannot be divided equally. Thus, 9 is 4 plus 1 plus 4, the unity in the center being indivisible. Furthermore, if any odd number be divided into two parts, one part will always be odd and the other even. Thus, 9 may be 5 plus 4, 3 plus 6, 7 plus 2, or 8 plus 1. The Pythagoreans considered the odd number, of which the monad was the prototype, to be definite and masculine. They were not all agreed, however, as to the nature of unity, or one. Some declared it to be positive, because if added to an even negative number, it produces an odd positive number. Others demonstrated that if unity be added to an odd number, the latter becomes even, thereby making the masculine to be feminine. Unity, or one, therefore, was considered an androgynous number, partaking of both the masculine and the feminine attributes. Consequently both odd and even. For this reason the Pythagoreans called it evenly odd. It was customary for the Pythagoreans to offer sacrifices of an uneven number of objects to the superior gods, while to the goddesses and subterranean spirits an even number was offered. Any even number may be divided into two equal parts, which are always either both odd or both even. Thus, 10 by equal division gives 5 plus 5, both odd numbers. The same principle holds true if the 10 be unequally divided. For example, in 6 plus 4, both parts are even. In 7 plus 3, both parts are odd. In 8 plus 2, both parts are again even. And in 9 plus 1, both parts are again odd. Thus, in the even number, however it may be divided, the parts will always be both odd or both even. The Pythagoreans considered the even number, of which the duad was the prototype, to be indefinite and feminine. The odd numbers are divided by a mathematical contrivance, called the sieve of Eratosthenes, into three general classes: incomposite, composite, and incomposite composite. The incomposite numbers are those which have no divisor other than themselves and unity, such as 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, and so forth. For example, 7 is divisible only by 7, which goes into itself once, and unity, which goes into 7 times. The composite numbers are those which are divisible not only by themselves and unity but also by some other number, such as 9, 15, 21, 25, 27, 33, 39, 45, 51, 57, and so forth. For example, 21 is divisible not only by itself and by unity, but also by 3 and by 7. The incomposite composite numbers are those which have no common divisor, although each of itself is capable of division, such as 9 and 25. For example, 9 is divisible by 3 and 25 by 5, but neither is divisible by the divisor of the other. Thus they have no common divisor. Because they have individual divisors, they are called composite. And because they have no common divisor, they are called incomposite. Accordingly, the term incomposite composite was created to describe their properties. Even numbers are divided into three classes: evenly even, evenly odd, and oddly odd. The evenly even numbers are all in double ratio from unity. Thus 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, and 1024. The proof of the perfect evenly even number is that it can be halved and the halves again halved back to unity, as 1/2 of 64 equals 32. 1/2 of 32 equals 16. 1/2 of 16 equals 8. 1/2 of 8 equals 4. 1/2 of 4 equals 2. 1/2 of 2 equals 1. Beyond unity it is impossible to go. The evenly even numbers possess certain unique properties. The sum of any number of terms but the last term is always equal to the last term minus 1. For example, the sum of the first and second terms 1 plus 2 equals the third term 4 minus 1. or the sum of the first, second,